Good day to all of you, ladies and gentlemen. Welcome to Kanjilal Clean Enviro. As you know that we are a business and research organization in environment engineering. We are continuously researching in air pollution control and water pollution control and flood control, and we are continuously redefining the state of the art in the field of environment engineering, in the field of air pollution control, in the field of water pollution control, in the field of flood control. Okay, so today we have decided that we'll walk you through the very basics of innovations that have been going on in the field of environmental engineering. So we are going to walk you through the innovations that have been taking place in the field of air pollution, water pollution control, and also flood control. Okay, and we also develop our products looking into mind, keeping into mind the state of the art. Whatever solution you get from our company is the most recent development in the field of environment engineering globally, the most advanced technology globally. So let's start from the basic of environment engineering. Okay, so this can be divided into air pollution control and water pollution control. Okay, air pollution control, in other words, you can say reducing carbon footprint in air, or it is also called smoke abatement. Environment engineering is all about reducing carbon footprint. Because basically whatever pollution you see in the air, it is hydrocarbon containing smokes, carbon containing particulate matter. In water, it is also mostly hydrocarbon containing waste that is entering the sewer, and via the sewer they are going to the river and seas and polluting the water and air. So that's why carbon footprint. Pollution is all about reducing carbon footprint. Okay. Now, the very basics of pollution control, basic of pollution control, both air and water. Okay. Yeah, in water also it is called reduction of carbon footprint in water. Now the very basic technology that has been going on in the world today since the times immemorial to reduce both air and water pollution, there are three main technology. The entire world is moving around three basic technology in environment engineering which is applicable for both air and water. What are those basic? As our company have researched and concluded, the three basic technologies of pollution control in both water and air are: first is ionization technology or electrostatic precipitation technology. Okay, which is both electrical and electronic technology. The second one is media filtration. Media filtration. It happens. It is used both in air and water. And the third is bioremediation. Yes, of course, we all have heard about bioremediation in water, but also there is some modern technology that is coming up in air pollution control, which involves bioremediation. Okay, so basically there are bacteria, beneficial bacteria, that is fitted inside air purifier, and when the air purifier sucks in the polluted gases, then the beneficial bacteria, they treat the gas, they treat all the hydrocarbon in gas, and then it releases fresh air, and the hydrocarbon in the gas is that is like a circular economy that can be reused as in the biofuel sector. Okay, so bioremediation is these days is also happening in air pollution control, right? Bioculture in both air and water pollution control, and this is a circular economy. Circular economy. So whatever waste the bacteria is producing, that can be reused. Okay, either for biofuel generation or for agricultural purpose. Okay, now media filtration. Media filtration, we can use both for air and water. We generally use polypropylene fibers. Polypropylene fibers, either woven, okay, let's put it this way, polypropylene fibers, they are either woven or they are non-woven. Okay, and in case of water, in case of air, these woven are basically these are our yarns that are converted into thread. Okay, and then this thread are then wounded over rotating mandrel over various angles, and then they can be they can be designed in various diamond shapes, diamond configuration, and the non-woven is actually needle felt. And this consists of random pattern fibers. They are bonded together by needle punching, by virtue of needle punching, and then they are compressed, and then they are cut. And here what you get, in case of woven, what you get is these have a regular pattern. Okay, and they have a very non-regular pattern. Okay, so these can be used for both air and water. Woven also both air and water. Okay, so this media filtration also sometimes consists of another category which is called the spun. spun or melt blown. Okay, spun or melt blown. What we do here is we take polypropylene granules. Polypropylene granules are nothing but byproduct of uh, fuel refinery. Byproduct of fuel refinery is the polypropylene granule. Then these are melted. Okay, I'm talking about spun or melt flown. Then these are melted by application of heat, and then they are air blowed, air blowed, air blowed over the same rotating mandle. Okay, same air blowed over a rotating mandle, and then they get deposited over the mandle. Okay, so here you have polypropylene granules. You have a blower here. You have a heater. You have a heater and a air blower here. These polypropylene granules are charged here. Then when the granules get melt, when the granules polypropylene granules melt, they are converted into fibers. And then these fibers, this is a rotating mandle. These fibers get deposited on the rotating mandle, and as they rotate, you get a cylindrical kind of a filter. So these are the three kind of fibers: woven, spun or melt blown, or non-woven. These three kind of media filtration are used both in air and water. Okay, and obviously they have a core inside, polypropylene core, at the middle of the cylindrical fiber, or you have a steel core, and the melt blown, they don't have any, they are core by themselves. Okay, and sometimes instead of polypropylene, they are also made up of polyester. Okay, polypropylene or polyester, these are mainly the two components, but also apart from these two components, we have many other kind of materials that are used to make media filtration both in air and water. Okay, ladies and gentlemen, next let us come to the ionization, electrical and electronic technology of air and water filtration. Ionization or electrostatic precipitator technology. We all know what an electrostatic precipitator basically consists of two electrodes. Okay, consists of two electrodes. You have a charge here. So this is positively charged. This is given a positively charged, and this is given a negatively charged, and either air or water can pass in between these two plates. Okay. Yes, if you have water, then we have a separate kind of grounding and earthing arrangement. But I'm just discussing the basic. Okay, I'm just discussing the basic technology. So when the air or water passes in, then the positively charged particulate matter or contamination get attracted and deposited on a negative plate, and the negatively charged particles, they get attracted and deposited over the positive plate of electrodes. Okay, and then again, when the positive charges are accumulated here, when the negative charges are accumulated here, then again these plates are given a negative charge. Instead of positive, they are given a negative charge, and again this, instead of negative, it is made positive. So what happens is these positive charges get repelled and they get removed, and the negative charges get repelled and then they get removed. Now again what happens, and after these contaminants are removed from the plate, they are flushed out, and then again they are back to their normal configuration of positive and negative, and then again the attracting the particulate matters and cleaning the air or water resumes all over again. Okay, these three basic principles are the heart of pollution control in the field of air pollution control and water pollution control, both. Okay, I hope this much is clear with you guys. Now let me start. Let me grab just one facet of environment engineering. Say for example, air or water pollution control. And one by one we'll delve deeper and deeper into each kind of pollution control, air pollution control or water pollution control, right? So let me start off with, what do you say, air pollution control, right? Right now I'll focus on air pollution control, right? I'm going to keep this aside for the moment, okay? Let's keep water aside for the moment because we have to discuss one by one, So, this air pollution control, as I told you, it consists of three aspects. The three kind of air treatment: the electrostatic precipitator technology, the media filter technology, media filter technology, okay, and of course this bioremediation in this field is an ongoing research. Okay, it is an ongoing research. There have been demo versions of bioremediation air purifiers installed in London and some other European countries, and they are still on the verge of trial. Okay. Now, electrostatic precipitator, I've already explained to you what an electrostatic precipitator technology is. It's the same technology, but this is quite expensive. It's quite expensive. It is not green actually. It is not very green. It consumes a lot of electricity. Yeah, it consumes a lot of electricity. So this is the reason our company, Kanjilal Clean Enviro, is not really much focused about electrostatic precipitator technology when it comes to smoke abatement. Yeah. But the case is the other way around when it comes to water filtration. That is, we'll get into that sometime later after we are finished with the air pollution control. Now, media filter. What do we use in the field of media filtration of air? We use certain kind of technology called the cyclone bag filter. There are certain kind of basically cylindrical bags, cylindrical fabric bag. I told you earlier this is either made of polypropylene PP or polyester. Okay, so cylindrical bag, fabric bag. These bags contains very small pores, So when the smoke enters, when the dust enters, then they get filtered here by the fabric of the bag, and then clean air is released. Okay, so here we have a cyclone bag filter kind of arrangement where you have kind of fabric filter inside a kind of apparatus, inside a kind of container, and here is the dust containing air moves in a spherical cyclonic way, and in that process, due to the centrifugal force, the dust gets settled and in the fabric, and clean air passes through. But this is not very um, very effective. This is not very efficient. Our company don't find this very efficient. What we find very efficient is the reverse jet bag filtration. Okay, so what we have here is basically we have uh, we have a chamber that is divided into uh, dirty chamber, and clean chamber. Okay, now here the dust from the factory of the chimney, dust from the chimney is going in, and then we have dust filters fitted inside the dirty chamber. Okay, many dust filters fitted in the chamber. There's basically hole here. There is hole cutting in the metallic sheet. That is, this is a metallic sheet. Okay, this is a metallic sheet that is separating the clean chamber and dirty chamber, and in the metallic sheet there are holes. These are called the cell plate. Okay, these are called the cell plate, and the diameter of the cell plate should be equal to the inner diameter of the bag. This should be equal to the inner diameter of the dust bag. Okay, and then this dust bags should be inserted inside the cell plate. So here, when the dust is coming in, they are hitting the outer walls of the dust bag, and then the dust bag filtering this air, and then clean air is coming out in the clean chamber. Okay, and it is going out. There is a blower here. There is a suction blower, and also there is an FD fan here, FD fan. Okay, which is pushing in the dirty air, and the suction air is pulling out the clean air, so that the dirty air can get filtered via these bag filters, and you can get clean air eventually out. Okay. Now, the game changer, the technology that we focus on in our company is, providing this dust bags of many different kind of fabric. Many different kind of fabric, many different kind of dust bag. So, what challenges you find in the industry is that sometimes you have high temperature, high temperature of the gas, or sometimes you have high acidity or high alkalinity, or you have stickiness, sticky dust, or you might have charged particulate matter. Okay, charged particulate matter. Particulate matter means dust. Okay, charged particulate matter. You can have. So accordingly, you need to have different fabric inside your dust bag. Your dust bag has to be made up of different kind of fabric to provide tolerance to these kind of high parameters. Okay, So this is what the heart of our smoke abatement technology consists of. The dust bag. This is the heart of smoke abatement. Okay, this is the heart. This is the technology that we have put the most focus on in this air pollution control industry, because the bags are the heart of the air pollution control. So we have bags made up of different kind of fabric. I'll tell you right now. So now let's divert our focus, our entire concentration into dust bags. Okay, let's focus exclusively on dust bags. Dust bag, or for that matter, dust bag fabric. This is going to be the focus of our discussion right now. Okay? So bag filter. This is a big technology that our company specializes into. We are capable of making and supplying bag filter of every kind of fabric. Okay, so now what kind of fabric do you need? What kind of fabric this bag filter is made up of? What do you need to counter all the challenges that you have in the air pollution control industry? In order to counter the challenges, this bag filter, these are made up of primarily woven. See, the basics are always the same. I've already told you the basic. We always walk on the basics. As usual, it is made up of woven or non-woven. Okay. Also, I told you sometimes we use spun. Okay, spun or melt blown. Okay. You remember the polypropylene granules? Polypropylene granules then heated and blown over a rotating mandrel. This is a mandrel. Rotating mandrel. Okay, it is spun. Mainly, it is of either woven or non-woven. I already told you this is made up of yarn having a repetitive pattern. Okay, and these are used where when these dust bags, when inside the chamber, I've told you the chamber is the dust bags. When the dust bags become dirty, then you have a solenoid here, a pulse jet cleaner here, and the air tanker here, air compressor, and then air tanker. From this air tanker, air goes into the compressor, and then by solenoid valve, this air is forced inside this bag to clean the bag. Okay, when the bag becomes dirty, you have to clean, right? And this consumes a lot of energy. Now, woven is used at places where you need a very low energy cleaning. Okay, you need very low energy cleaning. The smoke is not that much. There you can use woven. So here the you'll notice that here the cleaning mechanism would be shaker type, the cleaning mechanism would be shaker type, or reverse bag house type. Okay, low energy cleaning application you can use woven. Okay, but in this low energy application, if in high energy application, if you use woven, then the bag will tear apart. Okay, that will not last long. Now we come to non-woven. Non-woven, I have already told you, these two are the major, woven and non-woven. These are the mostly used bag fibers. Now this non-woven is used where you have high energy cleaning applications. High energy cleaning applications. Here you've got to use non-woven. Okay. For example, pulse jet cleaning system, dust collector. Okay, you can use this. Now this non-woven again is of two types. Non-woven is of two types. These are called felted or simply non-woven. Felted or simply non-woven. And another one we apply a membrane. Okay, we use membrane. So if you want me to recap what exactly non-woven is, so this non-woven is like you have fibers, non-woven. Okay, I'm not talking about spun. No, this is non-woven. Fiber, polyester fiber. Okay, these are broken. These fibers come in bag. Fibers come in fiber bag. This bag is cut open, and these big lump of fiber, these are broken into smaller pieces, and then they go through a roller that have spiked rollers. Okay, spiked rollers. These keep rotating. Okay, you see arrow? These keep rotating, and in between these two rollers, these are pushed inside, and then you have a spider cage like or spider web like consistency fabric. Okay, spider web. Spider web. These kind of spider webs we often use in Halloween parties. Okay, Halloween party spider web, that kind of spider web. Okay, and then these spider webs are arranged in many layers according to the thickness that you need. Okay, layers of spider web. Okay, layers, one on top of the other, like this, and then this entire bundle goes through a needle punching machine. Okay, needle punch. So these fibers are randomly placed. Okay, and then they are punched by needle like around 600 to 1200 times per minute, approximately. These are punched with needles, and then these are almost these fibers are entangled to each other with each other, and they take a almost uniform shape, uniform structure, uniform fabric. Okay, and then again they go through a compressor. Okay, this compressor, they keep rotating. Okay, they keep rotating, and these compressors, what they do is they compress them into very into very fine sheets, like very uniform sheet. You know, it's a very beautiful sheet structure. They come out from these compressing rollers, compressing roller. Then the sheets are cut. Here cutting is done. Then the sheet are cutting. They cutted, and bags. They're from them. All these bags are made. Okay. So this is a rough idea of non-woven, or these are also called felted or needle felted. Needle felt. Okay, needle felted. Now, why we use a membrane? This membrane is also called a Teflon. Okay, this membrane is so why we use a membrane? This consists of mainly PTFE kind of membrane. Okay, PTFE kind of membrane we use here. Now, why we use a membrane and here, because a dust bag, it does not have much filtration capacity. If you use a dust bag without a Teflon, then you see here, this is the dust collector. If there is no membrane, then the dust will come in, and they will keep getting deposited over the bag, and eventually it will become thicker and thicker, and a dust cake will be formed. Okay, dust cake. Dust cake is formed. Now this dust cake will keep filtering the dust from the air. Okay. So, but as long as this dust cake is not formed, these normal felted or non-woven bags, they don't have any filtration capacity whatsoever. Okay, they don't have any filtration capacity. Now, what is the problem? Problem is that you have to keep cleaning the dust bags more and more often, which leads to more wastage of energy in cleaning. Okay, and then if you keep cleaning, then the life of the bag will become lower, lesser and lesser. You have to keep change bag every often. Okay, and then obviously the temperature and pressure sensitivity is very high, so it is not very tolerant against very high temperature or pressure. Okay. Also, if you keep cleaning the bag very often, that means your solenoid air compressor apparatus is getting used more and more often. So the solenoid or the cleaning apparatus life will become lesser. So you have to change this solenoid more and more often, and your energy wastage will be more, energy consumption will be more, and also this will also lead to high plant downtime, very high plant downtime. Okay. Now, if you use a membrane, then you do not need this dust cake. Okay, you do not need this dust cake if you use membrane. If we use this PTFE membrane, then this membrane containing dust bag, this will require a dust cake to operate. This does not need any dust cake to operate. Okay, no dust cake needed. It stands on its own. PTFE membrane. This PTFE membrane you can compare to the non-stick pan that we use. It has a Teflon coating, non-stick coating. It is some over the non-stick pan. It is somewhat of that material. Okay, coating of non-stick cooking pan. Okay, it is somewhat like that, right? One more very vital thing that we use in a dust filter. What is the very vital thing that we use in a dust filter? Is, I'll tell you, is a screen. Okay? What is a screen? What is a screen? A screen is a very, very vital. It's very vital for you, for a client, to buy a bag that is supported by screen and PTFE. Okay, this is a very vital. Now the screen is so much vital that I'll give it a complete more than half of a board to discuss about a screen. Okay. Now, a screen of a dust bag. What is screen of a dust bag? It's a very vital backbone support of a dust bag. Okay. This consists of a net-like bonding of polyester thread, chemically bonded. Where is it placed? Where is the skin placed? The skin placed at the middle layer. It is inserted in the middle layer of the dust bag fabric. Okay, so this is the dust bag fabric. Okay, I'm just showing you. This is the thickness of the dust bag fabric, and here you insert a screen. While manufacturing this, you insert in the middle of the in the middle of the thickness of the dust bag fabric. Right. Now, let me discuss with you a screen analogy. So that you can understand it much better. Scrim analogy is, you imagine that you have a wooden plank and a rubber sheet. So rubber sheet, okay. Over this you put some ice, okay. Ice, and then you hit this with a hammer. You hit this with a hammer, okay. The moment you hit this with a hammer, instantly it gets raises like pop, like this, boom. This raise, and the ice instantly falls on the ground. But when you hit this rubber sheet with a hammer, when you hit this, then what is going to happen is this, okay. This rubber sheet, this is your hammer. You're hitting this, and so the rubber sheet will stretch like this, okay. When you're hitting with a hammer, it will stretch like this, okay. It will stretch like this. Here is the ice, and after it stretches, then only it will pass on the remaining force to flip the ice over, okay. So you can imagine most of the energy of the hammer, of the hammer is getting used in stretching the rubber, okay, and very less energy is getting transferred into the ice. Very less energy, okay. But here the complete energy of the hammer, complete energy of hammer getting transferred into the ice. So it knocks the ice just like this instantly, but here the ice gets knocked off at much lesser efficiency. So this is exactly, compares to a scrimless bag, okay, scrimless bag. Now this, okay, I'm dividing this. Now this compares exactly with a scrim bag, okay. And the ice, instead of ice, you imagine the dust. The dust gets knocked off instantly, in case of a scrimmed bag. But if you have a non-scrim bag, okay, this is non-scrim. In a non-scrim bag, the dust is not knocked off that at that in a desired efficient manner. So what happens is, if you use a scrim bag, then you need much lesser efficiency to clean the bag, okay, because in order to clean the bag you have to knock the dust off, which compares to an ice. The dust is compared to an ice. So you just give one pulse, this is the bag, okay. You just give one pulse and all the dust gets knocked off here. And then again, after very long span of time, again you need to clean this. But here in the bag, in the scrimless bag, when you are when you're giving energy to clean the bag, then the bag is stretching, and the energy, most of the energy is getting used up in stretching the bag. So as a consequence of which, the shredding off or the knocking off of the dust is much lower. So you need to waste much more energy to knock the dust off if you don't have a scrim in your bag, okay. And because the bag is stretching, when you are cleaning the bag, it is stretching so much because of the energy, the bag gradually wears and tears, okay. the bag gradually wears and tears apart, and the life of the bag becomes lesser, so you have to change the bags very very often. So this leads to uh, much more expenses, much more, you know, much more expenses, much more plant downtime, more frequent changes of solenoid or cleaning machine, cleaning apparatus. You know, that's why it is always advisable to use a dust bag, with a scrim and PTFE membrane. Right now, as I told you, earlier, you know, the scrim is always woven. Okay, so dust bags are, okay, let me put it this way. Dust bags are either completely woven, okay, or partially woven. This is a very vital point, you know, that most of the people, manufacturers, they don't know. Dust bags are completely woven because we are giving a woven one that is meant for low energy application. And whenever you are using the non-woven, then also you have a scrim. Okay, also you have a scrim. Scrim is always woven. What is scrim? Scrim is always woven. So if you are using a scrim inside a non-woven, then it is partially woven. So a dust bag should always be completely woven or partially woven. Yeah. Now, if a dust bag is completely non-woven, then you should never buy that dust bag. That supplier, you know, is not doing justice with you. If a supplier is selling you completely non-woven, okay, completely non-woven, if selling you, that is wrong. Okay, so this will lead you to much more expenses, right? This will lead you to much more expenses. Always remember, your dust bag should be either completely woven or it is partially woven, right? And the scrim, you know, the scrim is a thread-like structure, and here the bonding, this is chemically bonded. Okay, these are chemically bonded, so it becomes much more stiff. Okay, the scrim bag is supposed to make your bag stiff, so it is also called stiff bag. Okay, stiff bag. Imagine the wood analogy. Okay, wood analogy. I'm telling you again and again. I always tell you, our company will stress you the vital points again and again, over and over again. Wood analogy. Sorry, it's not again. Wood analogy. Okay. Scrim is a stiff bag. Your bag should be stiff. You know why? Because you think about the wood analogy, not the rubber analogy. So give a hammer to the wood, and immediately the ice gets knocked off. So it should be stiff bag. Okay. Either. Okay. Now, there are many more points to discuss. Okay, there are much more detailed stuff to discuss here. Okay, it is not possible to discuss everything in a video. You know, it's impossible. So this is the reason you should ask us questions. You know, you should ask us questions, and we'll keep sending you materials on the uh, particular problem that your factory is facing, your client is facing. Okay. Now, this screen is always made up of polyester. What is screen made up of? Screen made up of polyester. Okay, polyester like this, chemically bonded, net-like structure. Chemically bonded, net-like structure. Okay. Now, as I told you that this screen we can play with different kind of materials. You know, this with using this screen you can play around with different materials as well. You know, to make the bag more resistant against, as I told you again I'm telling you, against high temperature, high pressure, high acidity, high alkalinity, charged particulate matter or charged dust. There is electric dust inside. There is electric charge. There is electric charge inside the dust. You know, stickiness, sticky charge. So when you have charged particulate matter, example, charged particulate matter, then the screen. Okay, let's make it more tidy. Yeah, you have charged particulate matter, then the screen is made up of metallic wires. Metallic wire. Otherwise, your bag is going to burst. Okay, if you had charge particulate inside, then it will burst. Okay, burst. In order to prevent bursting, we make the screen out of metallic wires. Okay, so that it will flow the charge through itself and ground and earthen, so there will be no bursting. Now again, if you want to make it, if the temperature is very high, you know, more than 120, more than 150 degrees centigrade, more than 170 or to 200 degrees centigrade, then we have a different kind of fabric. This is called Rayton fabric. Okay? Rayton fabric. Okay. Now, say for example, now this screen metallic wire, there's a name for it. This is called anti-static fabric. Anti-static fabric means the fabric is made of certain kind of material, and the screen inside is a metallic wire. So this is called anti-static. Rayton is a different kind of fiber. You know, different kinds of fiber. You know, for all these high temperature, high pressure, high alkalinity, high stickiness, we are able to provide different kind of fiber like Rayton fiber, you know, glass fiber, okay, and also if you need any additional protection, then we can use AOL coating over the fabric. Okay, AOL coating over the fabric. Okay, so like this, you are able to get from us many different kinds of fabric with which we are able to make the dust bag. Okay. Now we also make the, like I told you earlier, we have spun we have spun dust bag. So that is made up of polypropylene. Okay. Generally it is made of polyester. Generally it is made of polyester, but we also have polypropylene for very high temperature, very high pressure, and other very high parameters. Polypropylene is very robust. It is the most robust material, polypropylene. Okay, and for anti-adhesive, sometimes, yes, I've discussed stickiness. For stickiness, we have anti-adhesive fiber, with screen. Okay. So like this, we have yet another kind of spring, which is called the homopolymer spring. Homopolymer spring. So now, and apart from this, we have another category which is called the pleated dust bag cartridges. Okay, so this consists of a core. Okay, this consists of a core, a polypropylene or a steel core over which we have, we have folded over which we have folded polyester fabric. Okay, so it is almost like you have a handkerchief, you fold this, you have folded, it's folded like this, it is folded. Okay, and now it's wrapped all around the core. Okay, it's folded, it's wrapped all around the core. Now, because of this folding, the area of the fabric, the surface area of the fabric has increased many times. Okay, so because of the increased surface area of fabric, you have is equal to much more dust filtration efficiency. Okay, so here you have much more dust filtration efficiency and your and this is called the pleated dust bag cartridges. So most of the people that order, they order this pleated polyester, which has many more times so filtration capacity. So its filtration capacity becomes like 3 to 4 times, 3 to 4 times more filtration capacity. Okay, so this is the pleated polyester fabric, right? Now let's discuss a little bit about the efficiency, and then after that we'll wind up with this air filtration, and we'll start over with water filtration. Okay, and we'll get into water filtration in our next video. Okay, now let's wind up with efficiency of the PTFE membrane. Is now 99.99%. Efficiency with PTFE. Efficiency with no PTFE. Okay. Efficiency with no PTFE is 99.97%. Okay. There's hardly any efficiency difference, but PTFE, this will last longer. This will last much longer, and energy saver, plant downtime saver. Okay, money saver. It saves money, and in the end, yeah, if we use PTFE. Okay, this is all about air filtration that I could discuss over video. If you have more questions, your company has to get back to us. Okay, in our next video, we'll dive into water pollution control, where we'll also discuss flood control. Thank you so much. Thank you for watching our video. Please like our video, subscribe to our video, hit the bell icon, and I look forward. My name is Anurup Kandilan. I look forward towards collaboration with your company. Thank you very much.